Welcome back to the Scotti-BYTE channel, and this is Scott. Today I want to discuss some Docker roadblocks. So the LXD project, which I discuss on the channel all the time, was begun back in 2015, and it supports LXD containers and also LXD virtual machines. Docker was initially released in 2013, and it's different from LXD because it virtualizes only an application, whereas LXD containers virtualize the operating system, and virtual machines virtualize the operating system as well as all of the hardware. So the GitHub project Docker Compose makes the use of Docker a lot easier than the use of the Docker run command. So, however, managing Docker applications can be tricky. So what are the components of a Docker application? Well, first of all, you have the Docker Compose file, and that is a .yaml file, and it's used as input to download images and start containers and set environment variables. Containers are composed of images that either come from the Docker hub or perhaps another hub for Docker containers, or they're built locally on your machine with a command called docker build, and I've covered that on the channel before. So Docker containers are volatile and they do not store any actual data between runs. So data that is preserved between runs is called non-volatile data, and it's stored in volumes, which are folders mapped back to the Docker host. So most people think that backing up the Docker compose.yaml file in the volume folders is sufficient to back up a Docker application. And that is not always true, as we're about to see. So here I'm logged into a LXD container, and we're going to use an instance of Rocket Chat as an example use case. So when I create a LXD container, I go ahead and install Docker inside of it. And the reason for that is because I like to have one application per LXD container. There really aren't a lot of overhead issues with having additional LXD containers. They're so lean, it's really unbelievable. So in this particular case, I log in, and when I do an ls, I can say, oh, there's a folder called Rocket Chat. Well, that must mean that this application installed in this particular LXD instance is Rocket Chat. So I go ahead and cd into Rocket Chat, and I do an ls in here, and I see that it has a Docker Compose file, and because of a conversion I did at one particular point in time, it has a secondary Docker Compose file, or actually a previous Docker Compose file that's actually called Docker Compose.mmap.yaml. So it's really not the accurately used one or current one. And then I have a data folder, a Docker folder, a scripts folder, and an uploads folder. So all of the folder names in blue are actually non-volatile volumes. This is where data is stored between runs of Docker. And what Docker Compose does is Docker Compose has if we go in and we look at the Docker Compose file, Docker Compose has a services section. And this services section lists the names of your containers. So in this case, there's a container called Rocket Chat, but going down the screen, there's also a container called Mongo. And I believe if I go a little bit further down, there's a container called Migrator and another container called Mongo init replica. So these containers don't always run all the time. Sometimes they run and they exit, but in any event, they go off and they run and do what they need to do. So here's an example of a volume section, and it says basically that inside the container, anything in the container app/uploads directory should be mapped outside the container so it remains non-volatile into a folder called uploads, and we just saw that. And so if we scroll down the screen, we can also find some additional non-volatile spaces. For example, Mongo has a dump directory and also a database directory. And both of these volumes are non-volatile volumes that point to folders on the Docker host, or in my case, the Docker host is a LXD container, so it points to folders on that LXD container. And then we have also another volume down here for migrator, and you get the idea. It keeps going. The next thing we want to look at is how images get loaded. So if this Docker Compose is executed, it's going to go out to Rocket Chat and get a rocket.chat, and then it's going to load what it considers to be the latest version. So the latest version might be, say, 6.2.9, which I believe is the latest version right now. So this is a little ambiguous because it's going to get whatever the latest version is, but if and only if it is running for the first time and downloading a container. Otherwise, it's not really going to go out and do a Docker Compose pull to get the latest version. And in fact, typically in a running container, you're going to go ahead and have to update that container yourself. So if we go down here, here's another one, and this one specifically says go get an image for Mongo 5.0. So the original Rocket Chat that most everybody's running out there, if they have not upgraded, is running Mongo version 4.0, which has been deprecated, and their files actually say 4.0. And perhaps they have this set up as latest, but if their database on the disk is running Rocket Chat, say 3.8, and it's running Mongo 4.0, if you do and this said 4.0 down here, by the way, instead of 5.0, if you do a Docker Compose pull, that is going to pull the latest version of the Rocket Chat image. However, Rocket Chat version 5.0 and beyond does not support Mongo version 4.0, and now you've broken your application, and you've also probably corrupted the database in the non-volatile directory. So there's a lot of considerations that you have in regards to that. So we can also go down here and we can see that sometimes they're performing some little scripts. Other times, somewhere up here, I noticed there can be an issue where you do, say, a Docker Compose build, and where you do a Docker Compose build, basically you're not downloading the container, but you're building it from its components. So the thing that turns out to be important is it's important what's in the Docker Compose file, but it's also important what's in each of these non-volatile folder directories. And then the part that people don't really consider is the other thing that is important is the current versions of containers that are actually, I would say, in memory, but in memory is not really a good way to put it. The containers that have been downloaded and on your current Docker system. If you haven't upgraded Docker Compose in a while, you might have the old version of Docker Compose. And by old, I mean that Docker Compose version 1 had been around for quite a while, whereas Docker Compose version 2 started back in June of 2021. And to tell whether or not you still have Docker Compose version 1 is if you do a Docker space compose and you do something like list my folders out there, which is going to list all the component containers rather as part of the Rocket Chat application. If you get a syntax error here and you have to go back and say docker-compose, then you'll know that this is the version 1 syntax. And so there's the version 1 syntax, whereas the version 2 syntax is docker space compose space ps. And the difference is that your Docker Compose PS is showing you all the applications that make up the Docker Compose, or all the containers that make up the Docker Compose. We've got the migrator, we've got Mongo, Mongo Replica, and Rocket Chat that you could see when we went through the Docker Compose file. Whereas Docker Space Compose Space PS only shows the running containers, and it says right now what you have running is Mongo 5.0 and Rocket Chat latest. Another example of the difference in the syntax between Docker Compose version 1 and version 2 can be seen if you do a Docker space compose space ls, and it says that Rocket Chat is the name of the application and that it currently has 2 containers that are up and running. Whereas if we do a docker-compose ls, that is actually not a valid command, and it comes back and gives you the help. So again, if we do the docker space compose space ps, we get the listing of the running containers. If we do a ps-a, meaning all, then we get a listing of all of the containers, whether they're currently running or not. And off to the right hand side, you can see the status on 2 of those containers is exited, which means they initially ran when the application started, but they're no longer running now. So here I've moved over to my production Rocket Chat instance, and I'm going to do a Docker Compose images. So this doesn't really look a whole lot different from what we just looked at, but I can go out and do a Docker space images, and you can see here that I am running the latest version of Rocket Chat right now because I have the latest tag on here. But then I also have quite a few old Rocket Chat containers that are sticking around on the system. I also have more than one migrator container running on the system, and I don't really need those additional containers. Since I'm getting ready to make a change to my production Rocket Chat, I might not be confident that that change is what I want to do, and since my Rocket Chat is inside of a dedicated LXD container, I go out to my LXD dashboard and I make a snapshot of that container, which I call checkpoint. I submit that snapshot and it is done now. So now I have a snapshot of that container, so anything that I do to that container will not result in any particular problems. So I have all these additional Rocket Chat images that are part of my system, and they're not really currently running images, so consequently I don't really need them. And there is one command that you can do to remove orphaned volumes, orphaned containers actually, and that is the docker system prune -a and also -- volumes. And if I do that command, it'll say that this will remove all stopped containers, all networks not used by at least one container, and all volumes not used by at least one container, and all images without at least one container associated with them, and all build caches. So it's a relatively dangerous command, but hey, I've got a snapshot of that. So I go ahead and say, go ahead and delete those, and it's deleting some containers that are out there. And we'll just see what happens here. So now that it's finished the prune operation, if I go back and do a Docker images, I have still the same list of images. And if I do a Docker compose images, you can see that I only have the 2 images listed here, which are Rocket Chat, Mongo, and Rocket Chat. So it's really cleaned up the system. And to prove that it's cleaned up the system well, if I do a Docker compose down, it will stop Rocket Chat and it will stop Mongo. And if I start it back up again, it will go ahead and recreate the containers, because when you shut it down, it stops and deletes the containers, but it does not delete the images used to create the containers. And that's an important distinction. And in order to start Rocket Chat back up, we just do a Docker space compose up -D to detach. And you can see that it is in the process of performing a build. So this is kind of interesting because it noticed missing components as a result of our prune. And I guess this is going to be a really good exercise, because this is probably going to demonstrate exactly why sometimes you need to not have additional containers around, but sometimes you need to definitely have additional containers around. So in this case, it may turn out poorly, but normally pruning containers is not an issue. The point is, you have to really understand the application that you're running to understand the effects of these commands. And generally, having around old images on your Docker server doesn't really do anything except make the server larger. And sometimes having the wrong images in memory for the or wrong images, I should say, on your Docker system can cause problems with your non-volatile volume directories. So it seems to be starting Rocket Chat here. And of course, what it did is it did that Docker compose build command to run this migrator and this init replica, which is a part of that Docker compose file that we looked at originally. So now that we've run that command, I can do a docker ps-a, and you see that I have, well, let's make this smaller so we can actually see this. I know it's a little bit of an eye chart, but basically we have the Rocket Chat image, we have the Mongo image for the init replica, we have the regular Mongo image, and we have the migrator up and running, as well as the Portainer agent. So that's a good thing, because that's what we were looking for. So now if I do a docker images command, we only have the migrator and Rocket Chat, and then we have Mongo, and then we have that Portainer image that I had running out there. So the question is, does the Rocket Chat application still work after this prune? And the answer to that question is yes. Here I have my Rocket Chat client up and running, and it's working just fine. And if I go under my administration and look at my workspace, it's running version 6.2.9, which is what it was running before, and everything seems to be great. So here we are on the first image of Rocket Chat, or the first instance of Rocket Chat that I have running in this other LXD container, the one that I was showing you originally. And the way that I would update this normally is that Rocket Chat is an application where we don't update the database without some specific instructions to do so. So in this case, we would do a Docker pull rocket chat, and then we'd say rocket.chat latest. And that will go ahead and pull it. But in this particular case, it says that the rocket chat image is up to date. If that rocket chat image were not up to date, you would see that it had updated. And the next step we would do a docker-compose stop rocket chat. Actually, technically, it can be a docker space compose because I've been showing off the version 2 command. So that goes ahead and stops rocket chat. So now we're assuming we've pulled a new image. And if we pulled a new image, then we can go ahead and remove the old image. And the way we would do that is a docker space compose remove rocket chat, and we can say yes, go ahead and remove rocket chat, and so it removes the container. And then after that we would be doing a docker compose up -d on rocket chat, and it would go ahead and launch that rocket chat with the new installation. In this particular case, it's downloading this, and it is bringing that image back down because we had deleted the one that was there. But if we had multiple ones, it would have deleted that one at the time. So here we go. It's creating this, and it should start just fine after a little while. And after restarting that version of Rocket Chat, which is just running locally on my network, you can see that it is up and running and all the rooms and everything are available. Okay, so we saw the prune command, and the prune command is obviously fairly dangerous if you didn't know what you were doing. On this particular system, obviously we could list containers. And if you do a PS, as we saw, it lists the 2 Rocket Chat containers, which is really Rocket Chat and Mongo. If we instead do a PS-AQ, it'll list the containers, but this time it lists all of the containers, including the ones that are stopped, and it lists them only by container ID. So if I take off the quiet flag, then it'll list all of the containers with everything. The reason that the ID is important is because you can use the ID to stop a particular container with a Docker stop and then giving the ID command. Or you can actually kind of build yourself a little script, if you will, with this type of command, which is basically Docker stop, and then since we said list all containers in the quiet mode, it's going to bring back just the IDs, so it's going to really stop all of these containers. I'm not going to do that, but we have an option to do that. Another thing that we have an option to do is to remove all containers. So normally when you do a Docker compose down, it brings the applications down and it deletes the containers without deleting the images. Here, if we do a Docker PS-AQ, but we say remove, it'll go ahead and stop all of the running containers regardless of what their names are. So all Docker containers on this particular Docker node. Another reason why I like to run only one application per LXD container, and that way I don't have 20 or 30 Docker applications that I can affect due to a rogue command. And another one here is kind of like the prune. It says Docker RMI, which is remove images. So that technically is remove stale images, and it says give me the list of all Docker containers in that quiet mode, which means bring back only the IDs. but it says remove the images. So technically what this does is this removes all the images of any containers that are stopped, and it will give you an error message that it can't delete the containers that are running. In general, this is safe, but it might not be safe on Rocket Chat because you have here a couple of containers like the init replica and the migrator, which by default are exited after the container first runs. I believe it'll recreate them when you do the next Docker compose up-d. However, I really wouldn't want to bet on that, but we'll try it here and just see what it does. You see it went ahead and said that it deleted one of them there. So if I turn around and do a docker ps-a, we're still seeing the same containers there. So let's do a docker compose down. And it goes ahead and stops the application. See, looking up here, it was able to delete one container, and I suspect that it deleted maybe the migrator. It's hard to say. And then I'll do a docker compose up-d again, and see it's running that script inside the docker compose file. And so it's having to recreate the container, which isn't a bad thing necessarily, but it all kind of depends on your application. The two most dangerous applications I've found in Docker are pretty much Rocket Chat and a Discourse. Discourse can also be really tough. And Discourse is tough because it does have a Docker application, but it has pieces of it that run in the OS, and then it also has pieces that it runs inside of Docker, and the two communicate with each other. So now let's do a docker ps-a. It looks like everything's up and running. So the question is the app still working at this particular point? So we'll bring this up, we'll go over to the app, and we'll go ahead and repaint the screen and see if it can repaint. And in fact, it is up and running, so that did not hurt it. Anyway, I hope that some of these commands that I provided, which I will put in the show notes, are some help to people maintaining Docker containers. And I just want you to be aware of the fact that even though you do back up your Docker compose and you back up your externally mounted volumes, the non-volatile data, what also counts is which versions of which images are in the Docker instance that you're running, and how will the application come back up and run, and will it run correctly. So in summary, Docker with Docker Compose is an easy, or maybe I should have said easier way to deploy an application. However, sometimes installing an application in a LXD container provides more configuration choices and ends up being a little bit easier to maintain in the long run. A good example of that is a lot of Docker Compose applications may have components in the operating system or components that you wish to change, and they're not mounted volumes. So you have to search around inside the container and figure out which folders you should be mounting to a volume so you can make non-volatile changes to them. And I've discovered several applications that run that way. So backing up a docker compose.yaml file in the non-volatile volumes is not always sufficient to capture the state of an application. The versions of applications loaded or not loaded to a Docker instance can impact how an application can run. You should always maintain stale containers on your Docker installation, and having many stale or old containers around, or perhaps incorrect versions in memory, does not help you when you're restoring an application that you have backed up. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.